Hello friends, in this instructional video, we intend to connect an HMI from the LS EXP2 series to an LS PLC via an RS-232 network and then connect the LS PLC to an LS G100 inverter using the Modbus RTU protocol over an RS-485 network and network these devices together. In LS inverters, the addresses related to the network start and stop in LS inverters are as follows. The address for the target frequency or the frequency setting address is 5 hex and the address for start and stop is 6 hex. For start and stop at address 6, if you set the value to 1, the inverter will stop. If you set it to 2, the inverter will start in the forward direction. And if you set it to 4, the inverter will start in the reverse direction to ensure that start, stop, and frequency setting are controlled via the network. For frequency control via the network, the FRQ parameter in the G100 inverter must be set to 6. For start-stop control via the network, the RS-485 network, you need to set the DRV parameter in the G100 inverter to 3. Now let's go into the XP Builder software and the XG5000 software, which are for LS brand HMIs and PLCs, and write the relevant program to download into the desired equipment. First, I open the XP Builder software. I want to have a start button, whether for forward or reverse doesn't matter, a stop button, a numeric input to set the frequency, and here I want to see the inverter status. First, from the toolbox, I bring in a bit switch. As you can see, I need to assign an address to this bit switch. First, in the XGT panel, you need to specify your HMI model. Here, my model is EXP20702D, so I select my HMI model first. Now, in the controller section, you need to specify which brand and device you are going to communicate with. Since the PLC I have here is from the LS brand, I set the brand to LS. The PLC type is XEC because the PLC series I want to communicate with is the XEC series, specifically the H series, so I select XEC, and since I want to connect to the PLC via RS-232, I select XEC link. So this is the device we want to communicate with. Now, under which network do we want to communicate with the LS PLC? As we said, via RS-232, so here we set the protocol to RS-232. If you set it to RS-232, your COM2 will be activated here, meaning you can use COM2 on your HMI. To connect to the LS PLC via RS-232, there is a detail setting here where you need to specify the baud rate, parity, stop bit, and station. I've set the baud rate to 9600, data bit to 8, parity to none, and stop bit to 1. As for the control address number, or the ID, we set it to 1. So these are the settings I need to configure in the HMI, and I have to select the device I want to communicate with, as well as the network settings that will connect me to the PLC. Now, as we mentioned, here we have brought in a bit switch. In the bit switch that we brought in, we need to assign an address to this bit switch. Here, we click on this option, and a page opens up asking whether you want to use the internal addresses of the HMI or the addresses of the device you want to communicate with. Well, here I select XEC link because I want to connect to the LS PLC via XEC link. For example, I assign it the address MX0, which means my start address is MX0. I find it and confirm again, so the address for my start is MX0. For the stop address, again, I select XEC link here, choose the LS PLC, and assign the stop address as MX1. So the start address is MX0 and the stop address is MX1. Now, since I want to set the frequency and input the frequency value, I need to bring a numeric input from the toolbox onto the page. I bring in the numeric input, and as we said, we also need to assign an address to this numeric input. Which address? From the addresses available in the PLC, since my data type here is integer, I selected, for example, MW100. This means that any value I enter into this numeric input on the HMI will be written to address MW100 in my PLC. I confirm this, and I confirm the other settings as well. I've placed an image related to the G100 inverter, and from here I also selected a bit lamp. Now I go into the XG5000 software and start writing the program for the PLC here. Well, in the section, when I click on the system, a page opens. My channel 1 is related to RS232C, and my channel 2 is related to RS485. Since my PLC is supposed to connect to the HMI via the RS232 network, I need to configure the PLC network settings to match the settings I set on the HMI. I had set the baud rate there to 9600 and the station to 1. So here I also set the baud rate to 9600 and the station to 1. Now we said the address related to my start in the HMI was MX0. On my page, I bring in a normally open contact and place it here, and I name it according to the address of this normally open contact, which is MX0, because my start there is MX0. Well, move what value? The value 2 into MW10. Why? Alright, I click on the system again. I said that I also want to connect to this LS inverter via RS485, meaning my HMI is supposed to connect to the PLC via RS232, and the PLC is supposed to connect to the inverter via RS485. RS485 is channel 2. I set the baud rate again to 9600 and the station to 1 on channel 2, because in the LS PLC we want to connect to the inverter via channel 2, which is RS485. Here, for our second channel, we set the option to use P2P, and after setting it to use P2P, here in internal P2P, we add an item so that our P2P channel appears here. After this page opens for us for our channel 2, we set the P2P driver to Modbus RTU client because our PLC acts as the client, and we click OK. In the P2P block, we need to fill out a table here. So we are supposed to do both. We are going to write the frequency value and also the start value. As we said earlier, if we send the number 2 to address 6 of the inverter, it will start in the forward direction. And if we send the number 1, it will simply stop. So for the inverter, in the first row, I say write. Conditional flag every 100 milliseconds. Comment type is continuous, data type is word, data size is 1, and our station number was set to 1. Now from which address? I say inverter, I go into the table, select setting, and it asks where to read from. I say read from MW100 because I had set MW100 for the frequency value. If you look in HMI as well, I had set MW100 as the address for frequency. You see that the address for frequency in HMI is MW100, meaning whatever value I enter here will go to MW100. So in my table here, I set MW100, put a move, and MW100 is transferred to inverter. Now for frequency, I say go and read from MW100 and store it in address 4 of the LS inverter. We said that the address for frequency in LS inverters is address 5, but in the network, for some devices, you need to subtract 1 from this address. So we give address 4. According to this, the value you enter in MW100 is read and saved in which address? Address 4 of the LS inverter, which is related to frequency. Now for start stop, again I select channel 2, mode is write with RTU client every 100 milliseconds, continuous, data type is word, station is 1. Read from address MW10 and store it in address 5 of the LS inverter. We said start stop is address 6, subtract 1, so it becomes address 5 hex for the inverter. There we had set the start stop address as MX0. As soon as you give a pulse to MX0, activate it for a moment, it sends the value 2 to the address, right? In MW10 we said in LS inverters, if you send the value 2 to address 5 or 6, it starts in the forward direction. If you send the value 1, the inverter stops. We had also set MW10 so that its value goes into address 5, which is 1 less than address 6, and is related to the start-stop of the inverter. Then, what did we say MX1 is for? It's for stopping. So that the moment this MX1 terminal is activated, the PLC sends the value 1 to address MW10, and MW then sends the value to address 5 of the inverter, stopping the inverter. So this is the program we wrote for our PLC. Just one point I should mention. The mode of the bit switches I selected in the HMI, I set them to momentary. That means even if you give it a pulse for just a moment, these bit switches get activated. I have set both MX0 and the bit switch related to MX1 to momentary. So these are the settings we need to do in the HMI and in the XG5000 program for our PLC programs we have written in the XP Builder software for the HMI LS, and the program we have written in the XG5000 software for our PLC into the HMI and PLC. Then we go to the equipment and test the program we have written together. To load the program into this LS HMI, we click on the download option. Here we want to connect via USB and load the program, so we click OK and then click download, and we wait for the program to be loaded into the HMI. So after we have loaded the program into the HMI, we go to the XG5000 software and click on the Online Connect option to connect to our PLC. Then, from the online menu, we click on the Write option to load the program into the PLC. After we have loaded the program, we go to the equipment and we also test the program. Now here we have the LS HMI. Our LS HMI is connected via RS232 network to the LS PLC through the RX and TX terminals, and it is connected through COM2. The LS PLC is connected via RS485 network using the Modbus RTU protocol to the LS G100 inverter. Here, in the frequency section, I set a frequency value for the inverter and send it to the PLC, and the PLC sends this value to the inverter. Since the frequency value in the LS inverter is entered in hundredths, meaning 1/100, whatever value we want to send, we multiply it by 100 and then send it to the inverter. For example, if I want to set the inverter frequency to 30 Hertz, I multiply 30 by 100, which becomes 3000. Now when I enter 3000 here, the inverter should display 30 Hertz. I press enter and you can see that the frequency value is 30 Hertz. Now if I want to start the inverter, I have to press the start button, and if I want to stop it, I press the stop button. I start the inverter and you can see its status changes to running. If I want to stop the inverter, I press the stop button and the inverter goes into stop mode, and you can see the frequency drops to 0. Now I'll send another frequency value to the inverter, for example 5000, which is 50 Hertz. You can see the inverter receives the 50 Hertz value. I start the inverter again and the frequency reaches 50 Hertz. I press stop again and you can see the inverter goes into stop mode and the frequency drops from 50 to 0. The settings we mentioned that need to be done on the G100 inverter are that the DRV should be set to 3 and the FRQ parameter should be set to 6. I start the inverter again, and in this video the frequency reaches 50 Hertz and the motor starts running at this value.